So in this topic, we're going to be focusing on sequences and series. We'll start by taking a look back to what you have done in previous grades, which is the quadratic number pattern. The quadratic number pattern is a pattern that has the highest term to the power of 2, and the formula is as follows: an squared plus bn plus c. This is the formula for the quadratic number pattern. In this number pattern, what you're trying to find is a linear pattern with the first difference of the sequence and a constant difference with the second, the second difference. The second difference must be a constant. It must be a constant difference. Let me demonstrate using an example. Let's say we have pattern 2, 6, 14, 26. If we do the first term's difference, let me just do this. This is T1, T2, T3, T4. So if we say T2 minus T1, it cannot be equal to T3 minus T2. Let's go ahead and start. It's 2, 6, 14, 26. 6 minus 2 is 4. 14 minus 6 is 8. 26 minus 14 is 12, ne? 12. And then this we must now check if this is going to be a linear pattern, and the characteristics of a linear pattern is that it must have a constant difference. So let's check. Term 2 minus term 1 is 8 minus 4 is 4, and 12 minus 8 is also 4. So that means the constant difference is the linear pattern has a constant difference. Therefore, this is a quadratic pattern, right? So now we must calculate for A, B, and C. So we will first start by calculating for what is A. We just have to do a couple of formulas. One that, as the series goes forward, we'll do proofs on how you find these formulas and how you generate all these formulas. A plus B plus C equals the first term, 2, and then we have 3A plus B, which is equal to 4, and then we have 2A equals 4. And then if we calculate this, we'll check, okay, what's A? A is just 2A divided by 4 divided by 2 on both sides. You get that A equals 2. And then you take the 2 that you have the value of A, and you move it here, and now it's going to be 3 multiplied by 2 plus B equals 4, and this is just 6 plus B equals 4. This implies that B equals 4 minus 6, which is minus 2. And now you have the value of A as 2, you have the value of B as negative 2, you have the value of C, which you don't know. So using this formula, you're going to take A plus B plus C equals 2. You have A, you have C, you have B. You're trying to calculate for C. So 2 minus 2 is 0, so C equals 2. The general term of this pattern would be Tn equals, what's A? A is 2n squared. What's B? It's minus 2n. What's C? It's 2. So let's just generate, let's just check to see if our formula is correct or our general term is correct by calculating T4. T4 is obviously 26. Let's see if, this, if we plug in 26, will generate what we're looking for. Alright, so T4 equals 2, 4 squared plus 2 or minus 2 plus 2. Then this will be, what's this? 2 times 16 minus 8 plus 2. And if we continue here, it will obviously be 32. T4 will be 32 minus 8 plus 2, or minus 6. And 32 minus 6 is supposed to be 26. And that's exactly what this is here. So that's just an example to illustrate the quadratic number pattern. Like I said, as we move forward at the end of the chapter, I then do all the proofs from the quadratic number pattern, which is supposed to be revision to the arithmetic sequence that we'll do in the next videos, the geometric sequence, the arithmetic series, as well as the geometric series. Thank you.